All right, so again, if you haven't started your engineering notebook for part replication, I'm in the part replication topic right now. There's this link, right? File, make a copy. I've shown this already a couple times. All right, then you rename it, put it wherever you want it, hit OK. Anyhow, then you start editing it, right? Put your name there. Table of contents, part replication, you probably have already started in there. This is going to be the Christmas. All right, and then this is going to be, if my part replication is 2 through 8, then this must be 9 through something. I don't know what. All right, so this is the old stuff that was in there, right? And now, by now, you should have some of your parts in there. But this I left in there so that you could see it as an example. Now, this example for the logo project. You guys did the logo project in your paper notebooks, people in class here. Um, Now you're going to do this project in a digital engineering notebook. So this format here, you might copy. You might just leave this where it is and replace this stuff as you go. All right, because this is all the stuff you need. You need the rubric, the directions in the rubric, screenshot it. I'll show you how to do that. And then you need the design brief, which is this information. You're going to have to do that. You're going to sign the bottom of each page. You're going to date all the entries individually if it's like a progress shot or a daily notes type shot. Planning sketch you're going to do on paper. So one of the students here just showed me their planning sketch. It was good. I gave him approval. Everybody, I'm going to do this, okay? You're going to have to draw a planning sketch on paper. And then you just take a picture of it. You can use, if you have a Chromebook, you can just use your screen, your webcam, whatever. On phone, no problem. Use your webcam on your Chromebook. And then really what you're doing with the plan sketch for this project is exactly what you see here. You're planning out how big it is. You're planning out kind of like different looks of it. And don't limit yourself to what you know how to do. All right. If you haven't finished the part replication stuff yet, there's some tools that we haven't practiced with, like revolve. Right. None of those part replications involve the revolve. But revolves are very, very useful, especially for this project. I've had a lot of people make bells over the year where they revolve the bell shape. I'm going to show how to do that in a video, how to make a bulb or like a teardrop shape. Then you can do different things there. But when you're doing your design, be creative. What you want to do in the design process is you want to get a design in your head, right? What you want something to look like. The overall feeling that this design is going to give you, the overall effect. You want to have a picture of it in your head. And then you're going to sketch it out just to kind of get some stuff down on paper so you know that it's going to work in terms of the size and shape and such. All right, so get your design down, get an idea down, and then we'll figure out how to 3D model it, right? Don't get too detailed with for instance, if you want to do a reindeer or something, you're not going to be able to make antlers that are in proportion to the body realistically, right? Because there's no way you could 3D print that. So you do have to have in the back of your head also in the design process, like, okay, wait a minute, I actually have to be able to 3D print this. General rule of thumb is no feature will print unless it's at least 0.05 or yeah, at least like 0.05, 03 maybe, 0.03 inches. That's about as small as a feature as you can make and have it print reasonably clear. Does that kind of make sense? I should write that down somewhere on the board. 0.05 to 0.03 is kind of like your limit inches as far as how small you can make something. And then you just start your daily notes, right? Oh. All right, so then, man, if it's that fast, that's crazy. That's cool. Anyway, the dates here, literally every day you work on it, you put a note in here. That's all it's got to be, just a simple sentence. And your engineering notebook, you do as you're doing things, right? You don't go back and add stuff in. You do it as you do it. So you're going to do the design brief now. You're going to do the planning sketch now. And then you're going to start your daily notes. All right? And then you might take a screenshot of your modeling as you go, right? And throw it in here. That could be your daily note, like a screenshot of what you accomplished that day. That's what a lot of kids do who are full remote. And then when you print it, take a picture of your finished print. And then you should always kind of make a note on the printing process. So when we print these, like we did the first thing we printed, I'm going to tell you the printer, the settings, the PLA. You want to keep track of all that stuff because every material has its quirks and specific things. So then, kind of while you're waiting to print it, then you can do your mechanical drawing, which we'll have to talk a little more about. It's been a little while since we did that. And that's about it. So you can use this and then replace the different things. Now let me remind you how to take the screenshot. So now over in the topic for this project, which this video will be in here, I'll update this as we go. Here's the directions and rubric. There's actually 2 pages here. All right, now I'm gonna go through this with you. So again, hopefully everybody, you know how to do screenshots at this point because you've been doing it for this project. So I don't need to show you that. So there's the instructions and the rubric. All right, so a little bit different here because there is points based on whether or not you satisfy the design requirements, right? So you really got to fit this thing in within a 3 by 3 by 3 inch cube. All right, so that's still pretty big for an ornament, right? Like there's your 3-inch size, right? So even your hook attachment you should try to keep in there. So if you for instance make a bulb, right, and you automatically make the diameter of it 3 inches, well now your hook attachment is going to be outside that 3 inches. There might be something that you make that goes longer than 3 inches, but only because it's very skinny or something. Like if you're going to make like an icicle shape, right? Try to make an icicle or something. You might want to make it 6 inches or something. But in order to kind of keep you within reason on the amount of material you're using, you're going to have to make it skinny. You guys kind of understand what I mean by that? Like it can go outside these dimensions if you show me and I say, okay, that makes sense because it's skinny and whatever, So, but you can't just make like a giant bulb, you don't have the time to print that or the materials. So must have 5 depth layers or 5 turning points of different depths. So what the heck is that? Well, for the logo project I had, you do three depth levels, I think. Well, I'm looking for basically 5 different modeling steps, so to speak. Like maybe you do a revolve to make a bulb. Maybe then you do a work plane and a hole, make the hole for the chamfer. It's got a little thing on the top maybe that you've revolved. And you make a work plane and a hole, and then maybe you want to make like some dots or something on its surface. So, we're up to 1, 2 things right now. Hole, maybe you chamfer the hole so it's smooth. So that's 3. Then maybe you do the dot. That's 4. Then maybe you pattern the dot. That's 5. Right? So it's like I'm looking for 5 different kind of usage of extrusion tools. It could be multiple extrusions. It could be, revolves, lofts. Maybe you want to make some sort of Christmas horn or something. I don't know. It's fun to experiment with all that different stuff. Again, get it in your head, get a plan on paper, and then I'll give you some pointers. All right. Additional surface features, embossed words, shapes. So you definitely want to get the year or something on here. I know in my family we decorate every year. It's interesting. One of my kids' favorite things is to see years on things, because we have like some ornaments, from when we were kids, and the kids, my wife and I. So our children are always like, "Oh, look at this, 1980, 1982. Those 1981. That's the year you were born, Mom." And good to have the year on there for, so that could count as a surface feature. The surface features and the depth layers, they sometimes kind of go together. They kind of can be, interchangeable. And engineered a way to attach a ribbon or a hook to its structure. So what this means is it can't just be some dumb hole right through the middle of it. So it's like a total afterthought. You want it to be engineered in terms of like, okay, if I put the hole there, it's going to hang the way I want it to hang. It's going to sit level. You're going to have to kind of estimate that. It looks okay. To it's designed to work and so on. So that's the big thing. So I try to give some examples of different things you could possibly do. The engineering notebook, design brief, planning sketches, printouts, documentation of the tools you're using. That's basically your daily notes. Highlight these in your daily notes. You have multi-view mechanical drawing, notebook format. That's your signatures, page numbers, dates, empty space, authenticity. The empty space crossed off, kind of not necessary with the digital engineering notebook. Can't really, nobody else can edit it anyways, so that doesn't really matter. Color photo printed object, and the ornament, making sure you've done those things I've told you to do back here, okay? So those points are off. It's not 45, it's 45 total. So, I got to go back and fix that. Probably re-upload this. I saw another typo down here. So these are the real point breakdown here on the rubric, okay? So this is an old project I've done over the years. I think I've made this my first year I taught engineering. So it's a fun one. Kids usually like this one and have memories of it the next year in engineering too and such. Okay, good luck. Coming around and help you. Those of you who are full remote for planning sketches, I guess drop them in your work drop boxes, okay? And I'll take a look at them, or maybe email them to me because uh, I'm gonna have to tell you it's good or whatever. So maybe emailing would be the best for that. Okay, have a good one.